Have you wondered why in Monopoly you tend to land on certain spaces more than the other? Is it purely coincidental, or is there a pattern behind every dice roll? Good morning, Prof. Xiangling. I'm Conan, and today I'm going to show you how something as simple as rolling 2 dices is actually governed by probability, and how understanding this concept will actually change the way you look at the game forever. Let's get into it. Every time you roll a dice in Monopoly, we're actually dealing with probability. Since a dice has 6 sides and we have 2 dices, it gives us a total of 36 possible different outcomes. Using the probability of events, and let's say we want to roll the number 7. Using 2 dices, there are 6 total possible outcomes. 1 plus 6, 2 plus 5, 3 plus 4, and so on. Using the formula of number of possible outcomes divided by the total possible outcomes, we will get a total of 6 out of 36. Now, instead of looking at one number, let's take a look at 2 numbers using discrete random variable. We let x be the possible number rolled with 2 dices, with 2 being the smallest and 12 being the largest. You might think that in Monopoly, your movement every turn is random, but it actually in the predictable range of 2 to 12.
In the game of Monopoly, when a player is sent to jail, they can try to escape by rolling doubles. The player is allowed up to 3 attempts to roll doubles. This situation can be expressed using binomial distribution, which describes the number of success in a fixed number of independent trials. Each trial has only 2 outcomes, success or failure, and the probability of success remains constant. In this case, the number of trials n is 3, and a success is rolling double.
As mentioned earlier, the probability of rolling doubles is equals to 1 over 6, and due to that, the probability of failure is equals to 5 out of 6. So, to stay in jail for all 3 attempts is equals to this formula, which also equals to 1 times 1 times 125 divided by 216 equals to 0.5787. And using the complement rule, the probability of escaping jail equals to 42.13%.
The probability of 2 or more events happening at the same time can be calculated depending if these 2 events are dependent or independent of each other. For example, the player can calculate the probability that they would both roll a 12 and not land on a property in the case where 7 out of the 11 places they could land on were not owned. So we can use a multiplication rule because these events are independent, and simply multiply both of the probabilities of these events to get a 1.77% chance. As for independent events, we can calculate the probability that a player will get an advance to go card given that they land on chance by using conditional probability. For this, we use the formula P advance to go times P land on chance given that we got the advance to go card. So for this, 1 over 16 is for the advance to go, as there's total 16 cards for chance cards, and 1 over 11 for this player's turn that they would land on the chance location. So for this, we get a 0.57% chance for the dependent event.
Markov chain analysis is used in Monopoly to identify the frequency that each square is visited on the board. This information is used by players to gain an advantage over other players by buying up lucrative properties.
So we are going to use the ergodic Markov chain, which states that for the number of times that each square gets visited will eventually be greater than 0. So to determine the player's next step, we'll use the player's current step instead of the player's previous steps. So the formula for the chain is this, where pi is the stationary distribution and p is the transition matrix.
The stationary distribution describes the long-term behavior of a Markov chain where time becomes infinitely large. The transition matrix with respect to Monopoly is a 40 times 40 matrix of all the possibilities moving from one square to another, only relevant to properties. As the game goes on, the Markov chain will gradually converge the stationary distribution labeled as matrix P here.
So for the Markov chain, we can only apply it provided they follow these 3 rules. They are irreducible, they are aperiodic, and they have a finite number of states. So therefore, we have come to the conclusion that the red and orange properties are the most profitable. Thank you, Prof, and have a nice day.